Hello everyone, welcome back to my channel. I am Annapurneshwari Parit, first year CSC student of Sri Venkateshwara College of Engineering, Bangalore, and I am up with a new concept that is corrosion. In this video, we are going to see what is corrosion, types of corrosion, difference between wet and dry corrosion, and the corrosion control methods. So let us begin with what is corrosion. Corrosion, it is nothing but it is a process whereby deterioration of actual metal is caused by reaction with its environment. Corrosion may cause mechanical failure of a structure. Corrosion takes place due to action of certain chemicals, moisture, atmosphere, etc. Chemicals such as ammonia or hydrogen sulfide initially tarnish and eventually corrode silver, copper, tin, mercury, etc. present in their alloy. Acids such as phosphoric, acetic and lactic acids are present in a proper concentration and pH can promote corrosion. Corrosion is classified into two different types. First one is a dry corrosion and the wet corrosion. Metals and non-metals come under dry corrosion, whereas dissimilar metals, heterogeneous surface composition, stress corrosion, concentration cell corrosion come under wet corrosion. So let us go through the different types of corrosion. First one is a direct chemical corrosion or a dry corrosion. And the second one is electrochemical corrosion or a wet corrosion. What is this dry corrosion? Dry corrosion is nothing but this type of a corrosion occurs mainly through the direct chemical action of atmospheric gases such as oxygen, halogens, hydrogen sulfide, carbon dioxide, sulfur oxide, nitrogen, hydrogen, or a liquid metals on a metal surface in the absence of moisture. What is a wet corrosion? Wet corrosion is nothing but this corrosion is due to existence of a separate anodic and a cathodic areas between which current flow through the conducting solution. This type of corrosion occurs when a metal is in contact with a conducting liquid and two dissimilar metals or alloy are immersed partially in a conducting solution. Difference between dry and a wet corrosion. The corrosion occurs in a dry condition is known as dry corrosion, whereas the corrosion which occurs in the wet condition is known as wet corrosion. Dry corrosion explains the absorption mechanism, whereas wet corrosion explains the electrochemical mechanism. The corrosion takes place in a dry condition is uniform, whereas the corrosion which takes place in the wet corrosion is not uniform. Dry corrosion is a very slow process, whereas the wet corrosion is a fast process. Dry absorption occurs on heterogeneous and homogeneous surface, whereas wet corrosion occurs on a heterogeneous surface only. Dry corrosion takes place when there is a direct attack of chemical substance in the absence of moisture, whereas wet corrosion takes place when there is an electrochemical attack occur in the presence of moisture or an conducting medium. The product after the corrosion accumulates at the place where the corrosion actually occurred, where the product after the wet corrosion accumulates at the cathode, while the reaction is carried out at the anode, that means at the positive pole. So these are the different pictures of a corrosion. First one is a differential metal corrosion, and the second one is differential aeration corrosion. And the differential aeration corrosion is which has two different types, which is fitting corrosion and a waterline corrosion. So let us go through this corrosion deeply. Differential metal corrosion. Differential metal corrosion is nothing but it occurs when two dissimilar metals are in contact with the one another and exposed to the corrosive conducting medium. The metal with the lower electrode potential act as an anode, undergoes oxidation and gets corroded. And the other metal with a higher electrode potential act as a cathode, undergo reduction and protected from the corrosion. The examples of differential metal corrosion are tin coating copper vessel, steel pipe connected to copper plumbing, bolt and nuts made with the different metals. And the next one is differential aeration corrosion. Differential aeration corrosion is nothing but when a metal is exposed to different concentration of air or oxygen, the part of the metal is exposed to the lower concentration of oxygen become anodic and undergoes corrosion, whereas the other part of a metal is exposed to the higher concentration of oxygen becomes cathodic and remains unaffected. This type of corrosion is called as a differential aeration corrosion. And the example for differential aeration corrosion Iron rod partially immersed in a NaCl solution. Part of a metal immersed in the solution is exposed to lower concentration of oxygen, becomes anodic and undergoes corrosion. Whereas the part of a metal outside NaCl solution is exposed to more oxygen, become cathodic and remains unaffected. What is Pittin reaction? Pittin corrosion is nothing but it is a localized accelerated attack resulting in the formation of pinholes, pits and cavities on the metal surface. It is due to the breakdown or a cracking of a protective film on the metal at a specified points. This gives rise to the formation of a small anodic and a large cathodic areas. Once a small pit is formed, the rate of corrosion will be increased. Presence of external impurities like a sand, dust, water, drops, etc. on the surface of the metal can also be cause for this type of corrosion. In this case, the small part below the impurity act as the anodic area while the rest of the metal act as the cathodic area. Due to corrosion, a small pit is formed at the anodic area which grows gradually. Waterline corrosion. It is the another type of a differential corrosion. Corrosion is in a storage tank. H2O tank, marine structure, etc. is called a waterline corrosion. When the water is stored in an iron tank, it is found that the maximum corrosion occurs along a line just below the water level. The area above the water line is highly oxygenated and acts as a cathodic, while the area just below the water line is less oxygenated and acts as an anode and undergoes corrosion. What are the corrosion control or the protection methods? The important methods used to control the corrosion are design and selection of a material, protective coating. Protective coating like organic coating and the inorganic coating. Metal coating, surface conversion coating. Third one is the corrosion inhibitors, cathodic protection and the anodic protection. Let's go through what about a galvanization. Galvanization is a process of coating zinc on the base metal surface by a hot dipping is known as galvanization. The galvanization process is carried out as follows. The metal surface is washed with the organic solvent like CCl4, toluene, benzene, etc. to remove organic matters. The metal surface is treated with a dilute H2SO4 to remove the rust and the other deposits. Then it is well washed with a water and it is air dried by passing with the hot air. The metal is treated with a mixture of zinc chloride and ammonium chloride solution, which prevents the oxidation of a coated metal. Then the metal is dipped in the molten zinc at 4500 degrees Celsius. Excess of a zinc on the surface is removed by passing a pair of hot rollers, which removes excess of a zinc and produce tin coating. What are the applications of galvanization? Galvanized materials are used in fencing wires, buckets, bolts, nuts, nails, screw, etc. And the important note is that the galvanized sheet cannot be used for preparing, storing food because zinc dissolves in an acidic medium and forms a toxic compound. Thank you.